Okay, welcome to this video where I'll try to explain a bit the structure of a scientific report or thesis, like a bachelor thesis or a master thesis, or of a scientific paper, and we will look at common pitfalls. So I hope this will help you in structuring your work better and in a way that is accepted and used commonly in science. So the typical structure that you will find in 99% of the cases, at least in papers, we'll not discuss books now, is the so-called IMRAD, like introduction, method, results, and discussion. And it basically consists of 7 main parts that very often are split in subparts. But basically the main structure contains always an introduction, a section on related work, state of the art, a section on data, especially if you're working like in science and in like machine learning or data science. You have a section on methods, one on results, discussion, and conclusions. And in this short video, I'll discuss the 7 parts and explain you what should be in each, and some tips on what you should put in each section. So when you start explaining what you have done, right, remember that a paper or a report or a thesis has the goal of explaining someone what you have done and especially provide enough information so that someone can reproduce your work. This is actually quite important and is one of the cornerstones of science, is that people should be able to reproduce the work of others, to verify that what you're saying is actually true, right? And so basically at the beginning, what you want to do is explain what is the topic of your project, what problem are you trying to solve, and especially why it's relevant, right? And provide the necessary background. So why you're discussing this problem at all, why you think it's relevant, and why should I continue with your work, okay? Usually you start with the context, right? Problem background and why it's important. You have to clearly define the problem you are studying, okay? And the problem that you are trying to solve. So that means be very, very clear what you want to do, very, very concrete. Okay, you need to describe the main goal of your work, what you're trying to do exactly, right? If you're trying, for example, to build a machine learning model that is able, to recognize, for example, specific animal species, right? You have to describe exactly, for example, what kind of animals you're talking about, what kind of species you're talking about, how many species are you want to solve this problem for, and why should I develop such a model, such a tool, maybe for environmental purposes. Maybe you're working with an animal protection agency that needs to do some kind of monitoring, right? Remember that very often, not very often, so almost always in science, what you're telling is a story, okay? So it's, your report, your paper should tell the story of what you're trying to do. And so at the beginning, you have to kind of set the context of the story, okay? And so it's also important to highlight relevance about what you're trying to do. Why should I care? Right? Why you want to develop, for example, a tool to distinguish between animal species, right? Maybe you want to save some endangered species. Maybe you want to count the amount of species and how this number develops over the years to monitor if like some species should be put on the endangered list or something like that, right? So always give the reader an explanation of why is relevant, because just saying that, oh, you know what, I'll develop a tool to distinguish between those 10 species is not enough, because you don't explain why you're trying to solve this problem. Okay, and also something important in introduction, you should keep it as concise as possible. So you should not discuss technical details. These will come later. You should not discuss about the data that you're going to use. This will come later. This is like the part in the storytelling that will allow the reader to recognize the relevance, the background, why your problem is important, and understand what kind of problem you're trying to solve. generally speaking, you want to structure the introduction to have a certain flow. What it means is that it's generally a good practice to start with general context. For example, in our example of an animal like of your tool that wants to distinguish between species, you could start by saying why, for example, a specific species or a specific kind of animals or a specific geographic location has problems because maybe of poachers, maybe because of animals that are hunted also outside the law. So give like kind of generic context about why your problem is relevant, right? And then you narrow down to the specific problem, maybe to those specific 5 or 10 species or this kind of specific animals. Maybe you are looking at elephants or tigers or other kind of animals, right? And so you go from the broader context. So look, animals are endangered in a specific geographical location, and there are those kind of economical and like maybe ethical issues. And then you go down and you say, okay, of this kind of in this context, I'm looking at this specific problem. Okay, and after that, you should really go down to the specific research questions or hypotheses that you are addressing. Really trying to go down and saying, I want to build a tool that distinguish for those kind of tigers, this and for this and this reason. So you go from the broader context, you narrow down to the specific problem, and you narrow down to the concrete problem you're trying to solve. Okay, now once you've completed the introduction, and so you've given the readers a good context, right? You have given the readers the relevance of your story, right? Now what you have to do is, and that's very important, you have to go and look what state of the art is about what you're trying to do, the related works, right? What other people have been doing in the past years, right? Because maybe someone has already developed a tool like the one you want to develop or started what you want to study, right? So you should always try to provide an overview of the most relevant and recent research that is related to what you're trying to do, right, to your project, right? You should summarize the key results and, for example, like approaches used by others. And especially important is you should always try to highlight gaps in those kind of previous works, right? Because one of the goals of a paper or a thesis is also make very clear what your contributions are, right? And it's partly related also to what we were discussing before about the relevance of your work, right? Because you want to make very clear how relevant your work is and that what your contributions are. And that is only possible if you tell people about what others have done, okay? So you should always look on papers, like on GitHub repositories, if relevant, on books, right, on articles published, and see what others have already done. Okay, so you should always summarize relevant research that is related to the problem you're working on your project. Something very important is you should not structure your work chronologically, meaning that, for example, in 74 someone did that, and in 82 someone else did that, and in 83 someone else did that. But you should really try to do it on with a thematic approach. What it means is that, for example, you could say that to solve this problem there are 3 possible approaches, and for example, one is that, and in this area there are 3 research groups that have done that, and so in that area we can do so much, and so on and so forth. Okay, because otherwise it's very difficult to highlight what's really the state of the art, right? So because you are looking at them, sometimes more relevant works comes earlier than modern work. So you have to be very careful and try to really highlight how research developed and what is the state of the art, right? The state of the art doesn't necessarily mean is the most recent one, Okay, and very important is you should really highlight limitation and research gaps, right? If you're talking about our example of, like, for example, recognize animal species, right? Maybe you can easily recognize families of animals, right? Tigers from lions, but it's very hard to recognize specific subspecies, okay? And maybe so far people have worked and developed tools or analysis or have studied cases that only address a sub-part of the problem you're trying to solve. Maybe your problem is more generic. And so by highlighting those research gaps, it's very easy to really make clear what your contributions are and why you are doing that, right? You are addressing a research gap, right? You are addressing and studying something that nobody has studied before, okay? You should compare approaches. For example, you could find that to solve a specific problem, there are like 3 different approaches, and you should compare them to highlight which one works in which case, right? Maybe one approach works best for a specific case and another one works best for a different case, right? And then in this state of the art, you should also make clear how your work is kind of different from others. You could say, okay, those 3 approaches exist already and they have reached this kind of performance, and we know that and that, and what we discuss in this work is different because of that and that. You will discuss that longer later, but it's in the state of the art is also a nice place to quickly highlight small differences. You don't have to discuss your methods here. This will come later, but it's a good place to start highlighting what you're doing differently, right? Because you want to really make sure that people understand what you've done and what you've done differently. Okay, now, since we're talking about mostly project in data science, statistics, machine learning, you need a specific section on data. Okay, some people put that in the method section, and it's absolutely fine. This is more like a small nuance that you can decide on. But I suggest you to have a specific section, or at least a subsection of the methods one, about data. Okay, you really have to explain very well what kind of data you have used in your work. Okay, not only what kind of data, but like where the data comes from. Right? Maybe someone collected the data. You should actually explain how data was collected, even if it was not collected by you, because it can play a role, right, in the results of your work. Maybe the data is biased, right? Maybe, has specific characteristics. Maybe you are using images, and images have a specific resolution or taken at specific time of the year. Maybe, maybe only in summer, maybe only in a specific geographic location, because by knowing those things, you can then later also highlight what the limitations of your work are. Right? For example, if you develop this kind of like an image recognition system of something, and your images are taken only in spring, right? You may have issues when, on snow or on a glacier or on a different landscape, if the images are taken at a different time of the year. So by knowing the collection information, like how data was collected, what kind of like, statistical distribution of the data you are dealing with, this may help you in explaining also the limitations of your work, okay? And also here, you should also explain, like, not only describe the data set, right? And if you can, use visualizations, put examples in your scientific paper or thesis, show how the data looks like, okay? Also explain any pre-processing steps that you might have used, like normalizing, like dividing by a certain amount, changing the resolution of images, anything at all, okay? Also look at like the quality of data. Explain if you have missing data. Maybe, if you're going back to our example of an animal species, right? Maybe you don't have all the animals you want to study, right? Maybe some are missing. Maybe for some animals you have a lot less images than others. Maybe you have to impute techniques, right? Maybe some data is missing and you will use some placeholder, something so that you can use the data set. you have to describe that in very, very high details. Okay, remember, the goal of your work, of let's say of writing about your work, is to allow someone to reproduce what you're doing. So you need to have all information that someone would need to redo your work. So if you aren't sure if something should go in there, think about that. Would someone that is not you would be able to reproduce your work if the information is not there? If the answer is no, then you have to put the information there. Sometimes you have lots of information and having too much information kind of like stops the flow of the story. And so one way of solving this issue that you might face is to put lots of technical information in appendixes, and just saying that reference say that all the pre-processing steps are described in detail in the appendix, and you continue to have a generic discussion about the things. Okay, and also important is like if you especially if you're using machine learning and you have to split the data and validation and testing, maybe you use k-fold cross validation and other techniques. You have to explain how you do that, in the sense that you can explain that also in the method section. That's mostly maybe a more like, depending on your taste. Some people put even in the method section like a validation subsection where this is explained. But for example, if you prepare your data in a way that you split in advance your data set and you save the data set in different ways, you should explain that now. Okay, now, after you have explained the data, there is a very important section, and we need to discuss exactly what should be in here, and it's the method section. Now, the method section should actually give technical information about the methods you're using. For example, if you're using a specific neural network architectures, you should describe that. If you're using a specific statistical analysis, I don't know, algorithm, then you should explain that. If you're using a specific metric to evaluate your performance, maybe you're using accuracy, maybe you're using, you know, the mean square error or something else, you should explain here. In this section, you should not put any result, meaning that, for example, if you train a model, let's suppose, and you get an accuracy of recognizing your animal species of 98%, this 98% doesn't go in here. Okay, the only thing that goes in here is actually the methods you're using. So it's like a kind of like a technical, let me phrase it this way. So you put here all the technical information that someone would need to understand what you're doing. Okay, because sometimes, you know, everyone does things slightly different. So maybe you have, maybe you have used a specific neural network architecture, and you've trained the neural network architecture for a certain number of epochs with this method and this metric and this library, and you have to explain that to give enough technical information so that someone could reproduce your work. Okay, that's always your main goal. Very often, like expert in the field will not need to, let's say, the details to understand what you've done. But let me phrase it this way: not to understand what you've done, but to understand the methods. They know how the methods work usually, but they need to understand how you've used them. Okay, so meaning that very often you don't need to explain necessarily what the neural network is, right? You can put a reference and give like 1 or 2 sentences, but you have to explain how you've used them. Okay, and you need to be very clear. So any parameters that you've used in your, machine learning or statistical analysis should be in there. Okay, any kind of formula, approach, and so on. Okay, you can organize your sections with the subheadings. Okay, so that means that you can have a methods, and under the methods you can have, for example, neural networks, and then, for example, relevant metrics, and so on and so forth. It's not a problem at all if it helps in organizing the section. And especially important is to explain and justify your choices. So it's not enough to say, oh, I have this data and I've used method A and I've used metric B and that's it, right? You have to, based also, for example, on the state of the art section, you have to justify and say, okay, according to literature review, the most promising way of doing that is that and that and that, and my idea is that and that, and this is why I decided to test this and this and this. Okay, so always explain and justify your choices. Okay, and discuss why they're appropriate for your problem. If you're working with images, you will need specific neural networks maybe that works with images. If you're doing a statistical analysis and you want to compare, I don't know, specific groups of subgroups of subjects, you will need a specific statistical tests to do that. Okay, always make very clear why you use that, why is the right choice, and why you didn't choose anything else. Okay, give all the details, give parameters, method, algorithms. So avoid at all costs generic wordings like lots of data. For some parameters this happens. For some parameters doesn't mean anything. I cannot reproduce that. So you have to say for the value of the parameters 3, 4, 7, 11, this and this happens. Okay, so you have to be always very precise. Anytime you find something like lots of, large number of, small number of, always stop and look and give the numbers. Large number of inputs. What is a large number? A large number for you may be something, for me may be something else. Okay, so you have to tell like 300 over 2,577 of the inputs have this problem, and so on. Okay, and you have to explain evaluation metrics and techniques. So it's especially in machine learning, this is a key point, and also in statistics, like how you decide that your model is good or not, right? So for example, if you develop this tool to recognize animal species, you have to decide how you're gonna explain me and convince me that what you've done is good enough, right? Maybe you will choose accuracy and say we can recognize 98% of our test data or something else. But you always have to think about how you evaluate that your model is doing what you expect it to do. That's actually very, very important. Okay, once you've explained the methods, meaning that I have enough information to reproduce your work, so you have explained me everything from which tools you have used and so on and so forth. Now I want to know what the results are, right? As I explained you before, in the method section, you should not have like, we've reached 98% of accuracy, or we have reached an MSE of 3.7, or our model is better. That doesn't belong to the method section. Methods is only the technical explanation of what you've done, okay, but not the results that you got, okay. In section 5 or whatever number you will have in your thesis or paper, in the results section, this is where you put the numbers. Okay, so I've tried 10 models, and each model has got a specific performance accuracy value of 98%, the first model, 97%, the second model, and so on and so forth. Okay, so here is where you give the numbers. You don't explain anymore how models work. You don't explain anymore which parameters you have used. But you may have a large table, for example, if you have compared different models, some machine learning models, or maybe you have compared different like subgroups in a statistical analysis, or whatever you have to do, right? You will have here like structure, tables, figures that actually show the results, right? So you kind of split the explanation of how the methods work and how you have used them in the section methods and what results you got in the results section, right? So if I know already, like for example, I don't need to read about the specific neural networks, but I want to know the results, I can look in here and see, okay, what kind of results you got. And then I can go back to your method section and check for example, for how you train your model if you're doing a machine learning project, right? Or what kind of specific statistical tools, how you have implemented it, what kind of tools you have used, and so on and so forth, right? And you have to be very objective, and you don't interpret the results yet, okay? This section presents objective results without interpretation. That's actually very important, okay? You highlight key findings, for example. You can highlight that a specific set of parameters performs, for a specific model performs better, or that like something like that. But you don't discuss and interpret the results, okay? Here in the results, you have also to mention and discuss any unexpected result, meaning that if there is any kind of results that is very different from what you expect, you should actually put in here. You should never hide results, okay, even if they are bad or unexpected, and you should discuss every single unexpected results, meaning that the expectation is that if something doesn't work, you have to understand why, okay? Maybe, I don't know, maybe the model is not the right one for the specific data that you're using, or maybe the statistical test you're using is not the right one, or whatever, right? But you should always explain why something is not working. Maybe for a specific animal species of our example, your model is not working because maybe, I don't know, the image, the species is too small in the image, and your model has seen only images with large animals or something like that, okay? So that's actually very important. You actually discuss your results in the discussion section, okay? You discuss your findings, you compare to the existing literature that you have actually highlighted and listed in your state-of-the-art section, right? You could say, for example, our model gets an accuracy so high, while other models only get an accuracy so high, and so on and so forth, okay? You interpret the results. So you can actually study why something has worked, what the consequences are. You compare with existing studies, right? And especially the implications are actually quite important, right? Now we have a model that can distinguish an animal species, and we can do now that and that and that. And also important here is you should actually address limitations and suggest future work. Why you should address limitations? You should do that because by understanding limitation, you actually add credibility to your work, because you kind of show that you have looked at the points that are still open, right? So you better understand what you've done if you understand where it doesn't work, okay? Because your work will have limitations. Every work, every research project, every work has limitations, okay? So the meaning, what are limitations? Maybe, in our example of animal species, maybe your work will not work with specific animals, okay? Or maybe, as I mentioned, maybe will work only, like when images are taken in summer, or something like that, right? Whatever it is that your model is not able to do, you should actually discuss here. And it's typically good practice to conclude with a summary where you actually highlight how good your work is, or bad, but I hope that your work is good, and so on, okay? And then after that, you conclude your paper or thesis with the conclusion sections, and then you actually because some people, if I want to have kind of an idea about what you've done, what the results are, if they're relevant or not, I can even skip the methods, the data, and the results section and go directly to the conclusion. So you should actually summarize your key findings, right? And relate them, especially, this is especially important, you should relate them back to your initial problem. So you're trying to do that. So we started with this problem, and we have done lots of work, and we have solved this problem in this and this way, and now we can do this and this, right? So you don't interpret the results, right? You actually summarize them to give someone a good overview of what you've done, and especially what kind of results you got, right? And you reflect on their significance, meaning that, okay, now we can do that before was not possible, and so on and so forth, right? You highlight your contribution, so you can even say in the conclusion, this work started and had those goals, and we have been able to have the following contribution, and you kind of repeat the contributions that you have, citing the main results, okay? And you end with typically one try to end with a strong statement, say that now is important, now is, for example, it's possible to do that, and these will be used in that case, and so on and so forth. Okay, so those section. Let me go back to the main to the typical structure of the thesis and the 7 sections. Remember that this is a typical structure that you can modify in some form. For example, you could decide to put the data after the methods if you want, but very often methods are chosen depending on the data. So that's a typical kind of nice way of structuring that will work in most of the cases. In each section, sometimes the names are not exactly there. Like sometimes, like they're not called methods and they're called methodologies or something like that. But basically, the main idea remains. Okay. And remember also that your main goal is to tell a story, right? And so always try to think. And when you write those sections, always look at the previous section and think about, am I telling a story or are the sections disjointed? Okay. And the last point is feel free also, if necessary, to add subsections. If, for example, under methods, you have many sections, many algorithms and methods that you're using, maybe it's worthwhile to add subsections to help people better understand what you've done. Okay? Now, this is mainly a very short introduction on how to structure work. I hope it was helpful. Of course, I haven't talked about the tools you may use, for example, to look for literature and so on and so forth. But this should give you enough information to at least understand how to structure a thesis or a scientific report or a paper.